just wait a moment, or shall I just begin? Okay, perfect. Yeah, then hi everybody. My name is Michael Engel. I'm a senior software engineer at Red Hat, and today I'd like to talk about Eclipse BlueChi, multi-node service controller. And for this presentation, I'd first start by introducing it a bit and moving on to the architecture and components that it comprises of. And in the third part, I'd give more technical overview about the features that it provides based on a use case example. So what is Eclipse BlueChi? Well, in order to explain what it is, I'd like to have a look at the problem that it tries to solve. In a car, we usually have one or more ECUs where services are communicating with each other, either on the same node or on a different one. And this is depicted here in this small picture. And what you also can see there is the term containerized. So containerization is considered a key enabler, or one of the key enablers of the software-defined vehicle, which means we need a workload orchestrator that is able to, well, control containerized applications. And you might think, well, maybe, what about Kubernetes? Well, Kubernetes was built for the private and public cloud, where completely different constraints and expectations are applied. For example, you have the design principle of eventual consistency, so eventually reaching a target state at some point, and thinking about this principle in a car, when you hit the brakes, eventually stopping might not be good. So you need something that is deterministic, so you know what runs when, where, and because in the car we have resource constraints, which are not there in the public or private cloud, it needs to be as lightweight and as fast as possible. And of course, ideally, we can certify it as functionally safe. So we thought a little bit, are there maybe any tools that we can already use or build on top of? And we found, well, systemd basically ticks off all the boxes. It's been around for years, it's very well tested and used in a wide variety of operating systems. So yeah, the only thing that we needed to add was adding this multi-node management aspect. And this is exactly what BlueChi tries to provide. Like an extension to systemd for multi-node environments with a focus on these highly regulated ecosystems, such as cars. As a technical detail, we chose to implement it in C. So the resulting binaries are around, I think, 0.5 megabytes or so. But you don't need to install all the components. And that brings me to the second part. What components are there? Well, as I said, the very basis is essentially systemd. So in this example, we have three nodes, a main and two worker nodes, where we have already a systemd instance running and are thus able to control these local services. The first part that BlueChi adds is a BlueChi agent. And it connects itself via a Unix socket to systemd and is thus able to use the dbus API that systemd provides and control the services there locally. We also register on events that systemd might emit. For example, when you start or stop a service, we get notifications about state changes or property changes and so on. And as you can see, we need to deploy this agent on each node that we want to manage. And each agent is connecting itself to the second component, which is the controller. The controller is a centralized application which has peer connections to these controllers, to these BlueChi agents. And that means an agent cannot interfere with another agent on a different node. And we use for this as a mechanism TCP/IP. And yeah, well, this communication channel is basically unencrypted by default because dbus doesn't provide this or was built differently for local machines. So what you might want to do if you want to secure this connection is to set up a double proxy, or at least we recommend that approach. So you would basically spin up, for example, an HA proxy on each side at the controller and agent side, and connect agent and controller to this, which then takes basically care of the encryption. But you don't have to. So in a sense, it's rather simple by default. Yeah, and by this, we are already able to control basically services remotely from the controller. But we don't do any state management or so inside BlueChi. The only state we might have is in the local systemd. But for an overall state management or across all nodes, you might want to implement your own application. And that's basically where you can then use the public dbus API that BlueChi provides on the local system bus. And because it's a dbus API, you can basically implement these applications in any language you want. Rust, C, Go, Python, whatever you want. And the BlueChi CTL is basically a reference implementation that we ship by default when you install BlueChi. It is supposed to be a developer or system administrator tool that lets you manage the services across nodes manually. So with this setup, we basically know about all the core components. And well, let's have a look at what we can do with them. Let's see Eclipse BlueChi in action. And for this, I'd like to use this example use case. Assume we have an ECU where we have a managed application running, which gets some data from some tire sensor via CAN bus and provides this in a REST endpoint to some other application, in this case the monitor, which is running in a completely isolated environment, here called QM. And well, now let's try to map this to something we can develop on. The ECU is going to be a virtual machine. You can take any image you want. And the larger and underlined name is basically the node name. So the virtual machine is called VM. And here we install the BlueChi CTL. We also install the controller and the agent, and have the manager and the sensor application encapsulated in systemd units. For the communication, we just use vCAN. And this isolated QM environment is represented by this worker container, where we have then also a BlueChi agent running, as well as the monitor service. Yeah, this is basically the start setup. But in order to get it running, we need to configure it properly. So the controller and agent both read in some configuration files, which are, well, in an ini-style format. For the controller, we have the section BlueChi-controller and specify the port that it is listening on for any connection requests, and the allowed node names list. This is essentially a whitelist for all the nodes that we expect to be there and that BlueChi expects to manage within this system. And in this case, we just want to have this VM and worker node present. Same thing for the agent, actually. Here we just specify the name. In this case, it was the virtual machine. And we can specify the address, so the host and the port of the controller. We can also use the field manager address, where we could specify a Unix socket or whatever we'd like to connect to. And yeah, with this, let's use BlueChi CTL to interact with the system that we set up. In this specific case, well, we use the BlueChi CTL status command to get an overview of the overall system. So all nodes that we expect to be there, as well as their current connection state, online or offline, IP address, and when we last seen them. You could also use a -w option to continuously monitor. And it's important to note that this is kind of event-driven, so we don't do any network traffic or so, just when the actual events are happening. The next thing that we might want to do is list units. So what applications are already there that we can use and manage on their respective node. With BlueChi CTL list units, we get a list of this for every node, as well as their active or substate. And with the -- filter, we could apply client-side filtering. In this case, we just want to get all the services. So there are, of course, a lot of other commands in BlueChi CTL: start, stop, restart, freezing, thawing, you name it. And if you're familiar with system CTL, this might look familiar, because it is. We tried to design BlueChi CTL to feel like system CTL, but for remote machines. And now that we know basically how to interact with it, well, let's start some service. And in this specific case, I want to start this monitor service inside the containerized worker node. And if you remember, this monitor application pulls basically some data from the manager. So it basically has a requirement that the manager is running. And the same applies for the manager on the sensor service, essentially. Because the sensor is emitting some data and the manager saves it, for example. So how can we resolve that? Systemd provides the nice mechanism to define dependencies inside the systemd unit files. And in our specific case, I wanted to specify when I start the manager, the entire sensor service starts as well. And I can do this with the simple ones here, like a very simple systemd mechanism to guarantee this. And with the after, I guarantee basically the ordering. From the monitor to the manager service, however, this is a bit tricky. This is not implemented by default because systemd looks at the local machine, not across machines. And this is basically what Eclipse BlueChi provides with the proxy services, which is essentially just a systemd unit template. You can see that by the little add symbol here in the once option. And this template unit you can instantiate multiple times. And after the add symbol, you have the name of that instance. For the BlueChi-proxy template unit, we defined the name to be structured like this. First the node name, underscore, then the target unit name. And by using this in the systemd unit for the monitor, we can easily resolve the cross-node dependency by using systemd mechanisms. So when starting the monitor, we get the manager and the sensor service started as well. So let's do that with the BlueChi CTL start command on the worker node for this demo-monitors.service. We get a result done, and then we can list the services filtered by this demo prefix. And there we see basically that the demo manager service as well as the tire service are running on the virtual machine, and the monitor service is running on the worker node. So far, so good. But what about containerizing applications. This was one of the key features that we wanted to have. Well, we will use the demo monitor service as an example, containerize it, and run it inside the virtual machine. And the way we do this is, well, in theory, we could just go ahead and write a systemd unit, which has all the necessary Podman or Docker commands to start the service or stop them. This is a bit tricky to do, especially to do it right, and quite cumbersome. So there is a neat little tool which is called Quadlet that we can leverage. And Quadlet is part of the Podman project, and it's essentially a systemd generator, meaning it runs every time you do a systemctl daemon reload, and it reads in Quadlet files, generating the respective systemd unit file with all the necessary Podman commands. So Quadlet is kind of an ideal way to run containerized applications under systemd. And, well, we are not limited here by just running containers. We could run pods, networks, volumes, whatever we'd like. And we get this basically, well, out for free for BlueChi, because we are building on top of systemd, and we just are using tools that are already there. So in this case, let's start the generated service with the, well, first, let's have a look at how such a Quadlet file looks like. Basically the same syntax as a systemd unit file, with the unit and the service section, for example, with the small addition that you have a container section as well, where you can specify the image that you want to use, as well as all different kinds of Podman arguments. In this case, I wanted to have the stop signal to be like a sigint. And when I place this file now on the file system, run a systemctl daemon reload, or using BlueChi CTL, Quadlet takes this file, generates the respective service file, and, well, we can start that with BlueChi CTL start on the VM, on the virtual machine, and we get the result done. We can check with, again, with the list units command if it's already running. This looks at only the, in quotes, only the systemd unit state. We can use Podman commands as well to check if the container is really there. And as you can see here in the second line, we got the tire monitor image or container running with the name systemd demo Quadlet monitor. So it basically prefixes the name of the unit file with systemd. Well, and that's it. If we do systemctl stop or BlueChi CTL stop, we stop not only the service, but also, of course, the respective container that's being run by it. And that's how you do containerized applications under BlueChi. The last topic I'd like to show you is how to write your own application, because BlueChi CTL, for example, provides a lot of commands already, but you might want to, for example, set certain properties of your unit, like the CPU weight. Or you might want to automate something, write your own state manager, whatever you'd like. And for this, I chose to write a Python script to set the CPU weight for any given unit on any given node. And, well, this I've done basically, as you can see here in this in the snippet, in line 2 with importing the BlueChi.api, which are typed Python bindings that we generate. The default, for example, DasBus or whatever Python library you can use, doesn't provide bindings, but these kind of type hints are, or sorry, they don't provide type hints. But these type hints are quite useful for prototyping. So we provide such bindings for Python. In line 12 to 15, we basically parse the CLI options, getting the node name, the unit name, and the CPU weight value. and then we call the function, where we create in line 5 essentially a node proxy based on the node name, checking the node status in the next line, in line 6, if it is online or offline. If it is offline, we just raise an exception, and if it is online, we call the set unity properties with the specified unit name and CPU weight. Well, and that's it. We can run this Python script and see that basically we can set the CPU weight for any given unit. And we can do so in less than like 20 lines, in 15 lines. So it's quite simple. But you don't have to trust me on that. I mean, would be nice if you do, but if you want to try it out yourself, I highly recommend the demo here that I've linked. Basically, these features that I've shown you are based on that. And if you try it out and figure out a bug or a feature that is missing, I'd highly, encourage you to open an issue or start a conversation with us. So we are happy to help you here to get a feature or bug fixed. Yeah, and with that, I'd like to conclude my presentation. Any questions?
Okay, great. Thank you very much. So, for questions, all right, good. I'm going to ask mine first. Have you thought about any use case? I have two, actually, because I know of a OEM that was using BlueChi, and one of the issues that we were having, that they were having, or someone was having, was all about, I think, something that goes out of the scope of System D, but we need, which is packaging, signing, verifying, and installing of these things. BlueChi assumes that it's there. The unit file and all those files are there, and you just launch them and run them. Is there plans to add support of doing any of those extra things that you need?
At least not that I am aware of. The thing is, we designed BlueChi with a specific, let's say, scenario in mind, that everything is kind of preset. In the automotive industry or in cars, you don't suddenly scale or do, scaling in the sense of like multiple nodes or so, or additional nodes. So the idea was more or less to pre-bake everything into the image. And if you want to like install new packages and so on, this is outside of the scope of BlueChi. You would basically need to do this in a separate like application or
using some other Linux package manager or PEX or something else.
Exactly. But this is also something that
or Symfony does that? Okay, all right.
Oh, okay. I didn't know about that actually.
So that is actually another thing that I want to talk about with them afterwards. But the BlueChi controller is the intention that is always running within the vehicle, or do you see use cases that folks you've talked to want to be able to control it remotely?
Very good question. So the ability to control it remotely, we also discussed this at Red Hat internally, but the controller is supposed to be always inside the vehicle, in the machine. If you want to do like communication integrated, for example, into Kubernetes or so, we did already some POCs, for example, building an MQTT bridge or some similar things to integrate it into other systems, like having your machine, your car running independently and managing it independently, but also being able to extract information from it.
The API that you had shown in the Python example.
This one?
Yeah, BlueChi API, is that something that you develop as part of your project?
Yes. These are these type bindings. In Python, you usually, for example, use a library called DustBus, but this doesn't provide any type-ins or so. You would just do like .get proxy or so.
Do you have something similar for other languages as well?
No, for example, for Rust or so. Wait a second. Do I have this by any chance there? Yeah, for example, for Rust, you would use like a dbus code generator. So you can imagine the API might evolve over time. And even though at the moment, we might introduce breaking changes. So you want to have the dbus specification in your development lifecycle somehow, generating then the code stubs for you. So you don't need to take care about the dbus or so. This is done then by this code generation library, and you can just use it similar to my snippet here.
Do you have an example in your repository that does that?
For the code generation, unfortunately not. Just the plain Rust code, like on the in the read.
Manually creating the dbus messages then.
Sorry?
Manually creating the dbus messages.
Yes, exactly.
It's basically just text messages, just textual messages, isn't it?
Yeah, there are some specifics to use this dbus API, but essentially yes. Yeah.
Okay, thank you.
There was a question back here. Yep.
So my question is targeting the quite other end, the service. What can a service be? Can it use, for example, AutoZor functionality, classic or adaptive or ROS 2, something like that? Or do you have to set up all those fancy things they deliver yourself? That's the question.
So if I got it right, so essentially you can use anything what you can encode inside a systemd unit, or anything that systemd is capable of, we are capable of as well with BlueChi. In terms of what you need to do, well, depends.
Depends. So I have to deal myself with diagnostics, with all those things. So there's no library available which have the functionality to do all those diagnostics, OBD, so that onboard diagnostics things, everything.
Could you repeat that? Sorry.
So if you have a car, you have a OBD plug, OBD2, I think it's now, and then a maintainer can put his device in and sees, okay, there was trouble with these devices. How to do this?
So
it's over all services, no?
So okay. So basically, you already wrapped this in your in some systemd service, right? Yeah. And then you could basically, in a custom application or whatever, or even with BlueChi CTL, monitor the state of these services, of course. So if they, for example, have trouble, they fail or so, you would get a notification. If they don't fail, if they just keep running and produce, let's say, error logs or so, then we currently don't support this. We had the idea basically to integrate also the journal D library to get you these logs, but so far there was no demand, so we didn't implement anything. But could be.
Any other questions? All right.
Regarding the controller, it's maybe a silly question, but what if it fails, it crashes?
Yeah.
Have you thought about solutions of redundancy, things like that?
Yes. Yeah. So you're basically aiming at the controller node is, or the controller itself is a single point of failure there, and you're right. It is. We had a similar question from one company that uses BlueChi already quite a bit, and well, the only solution there would be kind of providing redundancy, so providing multiple controllers that are running. We didn't want to provide anything like intrinsic be implemented in BlueChi, like for example, consensus algorithm or so, because these things get really complex really fast. What we instead do is we provide an API on the agent to tell them, hey, there is a new controller, switch to that. So when you're controller would go down, let's say you have a watchdog enabled that notices that, spins up, or maybe it's already running. However, it's basically using this switch API to the agents to tell them, please use the other controller. And of course, you have to, like, another problem there is to not end up in a kind of split brain situation where some agents are connected there, some there. So, yeah, we don't do that, as I said. We just provide the means so you could do that.
One other question, very quick, is so we have a way to specify where the workloads are running, on which node, right? And the controller is running on one node, so it's just a confirmation. If I, for instance, want to place the SSH daemon where the controller is, because from my understanding, that's the only way you can talk to it, right?
Yes.
You can, because you set both the controller and the SSH daemon on the same node, and then you, by just SSHing, you are able to use the BlueChi CTL command, right?
Exactly, yeah.
Okay.
Actually, I had another question I was just thinking now. Between the controllers and agent, is there any built-in authorization, or are you using some other mechanism that exists with the transport protocol?
Yeah, so the transport protocol, like dbus, like I said, it wasn't really designed for cross-node communication.
Right.
So it doesn't have this these means by itself. We also decided, because we are running it, or the use case was to run it in a car where the environment is, in quotes, considered safe, to not do that by default. But if you, like I said, want to have this, like I explained, this double proxy approach would be one possible ways to achieve that. Has pros and cons. Like, you have to do it kind of yourself, but on the other side, do you really need it sometimes? So yeah, that's why we decided for now to not do any authorization or so. We have this allowed node names list, basically, but in essence, anybody could register at the controller if he knows the IP and use the name. I think there is even a ticket already open for the authorization, but we didn't prioritize that for now.
Okay, yeah, because in most scenarios, we want to be able to dynamically update these software, right? To update and deploy without having to do a reboot and re-signing and re-verification of the entire image of each ECU. So
True, yeah.
we need some authorization, but the thing is, authorization is usually implementation or vendor specific. So like I might use one token method and someone will use someone else. So right now there is an assumed level of trust, but we could potentially consider adding in some pluggable one where I pass an arbitrary token. It's up to the agents to verify, or vice versa.
Exactly. And that was also one reason why we didn't provide anything out of the box, because we wanted to be able to vendor, not vendor specific, that you can do it yourself, essentially.
Plug in a vendor specific.
Yeah, exactly. Sorry. Yeah.
Okay, great. I think we have time. Yeah, we have time for more questions.
So I have a question about determinism. So we can specify the dependency of each service by using the once or after. My question is, so how we can specify the more precise the timing of each service. For example, this service should be executed after another service launched within 10 milliseconds, like this kind of.
So if I understood the question correctly, the question is not even about the after to order this, but having like a specific time frame that after a certain time has passed. Good question. I think there is no systemd mechanism to provide this out of the box. At least I I'm not aware of it. Well,
I guess we would do it at this level, right, though?
most likely, yeah.
Okay. So you'd have to do it at this level and when you're sending the commands down to the controller.
Exactly. So what you would want to do is like provide this information in your own state manager that resolves these dependency as well. I mean, what I showed with the BlueChi proxy is essentially one way you can do it. The other way, of course, is having your own state manager that knows what to run when, on which machine. Sure.
Okay, we have another one in the back.
So another question on the update mechanism. So software-defined vehicles, yes, do updates, but how is the update controlled? For example, if you update an ABS controller while braking, I think it's not the best idea.
Yeah.
Yeah. So how is this controlled, and how is such a scenario prevented?
Easy answer for BlueChi, we don't.
You don't. Okay,
Yeah.
you don't.
Yeah,
So
at least for us, that's a completely different topic in quotes. We probably will leverage BlueChi to some extent there, but we are still discussing also how to do this.
Okay, and how comes the software on the node? Is this the duty of BlueChi, or is it also not
Also not part of BlueChi. What you could do basically is with this, wait a second, where is it? Yeah. But basically, if you specified in the image a specific image registry or so, then you can point to that. If it is then a registry in the car or somewhere else, it would try to pull it. If this is the best mechanism, probably not. But it is at least, let's say, one thing you could use.
Yeah. Okay.
Last call for questions. Oh, well, all right. All right, last question.
I was wondering, is there, because I come from the cloud kind of paradigm, so when you have a Kubernetes cluster, you have one node, which is the master node, and you talk to that one, there's the API server, and so on. In BlueChi, it's similar. We have a node which runs the controller process, but what I was wondering is there a way in the BlueChi, when you define where to run services, for instance, to label a node as such, or is it, let's say, hidden? You have to know that that one is the master. I mean, is there a way to encode it? I want to run this thing only on the master and not...
Good question. So there are no labels or so. So from the cloud side, you wouldn't know. You just, well, have to know. Yeah.